Hi, welcome to the second unit on methods. In the previous unit, we have learned about how to write a method using the def keyword and the return keyword. So now we are going to talk about how to use a method, how to call or invoke a method. Now you are thinking from the perspective of the user, not the person who writes a method. Okay, this is the syntax. All you have to do is put the method name here, round brackets, and if the method takes in X number of input parameters, you pass to the method X number of values. I'll show an example, nothing beats an example. Okay, now I'm going to interactive Ruby. I'm going to write a method called called to the power or square, def square x. Now what this method does is it returns x to the power of 2, x squared. Alright, so now I've written a method called square. It is now safely in memory. How do I call the method? Method name square followed by values. In this case, square takes in one input parameter. Square has one input parameter, and hence when I call square or I invoke square, must pass in only one value. You see, when I pass in 100, what happens is that method runs, x gets to store 100 in this case, and I calculate 100 to the power of 2, which is 10,000, and I return 10,000 to the caller. This is the return value. Of course, you can always store the return value in a variable. So in this case, the value stored in answer will be 10,000. So if you want the return value, this is a method call, right? The return value can be assigned to a variable, so that you can use that value later. Let me give an example. Another example: square is being called to 6.5. All right, and the return value is 42.25. So of course, if you try to call square and pass in two values, you get an error. It says wrong number of arguments, 2 for 1. It's expecting 1, but you're passing in 2. Same thing. You pass in nothing. Wrong number of arguments, 0 for 1. Now when you call a method, if you do not want to pass in any values, you can call it this way without the round brackets. So it's the same thing. So that's why you get the same error. Wrong number of arguments, 0 for 1. Okay? So when you want to use a method, you need to know two things. Number one, you need to know the name of the method. Number two, you need to know the number of input parameters. So if it's square is supposed to take in one value, when you call it, you must pass in one value like this. You can't pass in two values, you can't pass in 0 values, you can't pass in 3 values. Oops. Control C, error. Okay, you can't pass in the wrong number of values. That must match. Okay, now there's a huge disadvantage of writing a method in IRB like that. Okay, like this. Now, there are two disadvantages. One disadvantage is that if you need to edit the method, so for example, you want to edit the formula here, instead of returning x ** 2, you want to change it to x times x, you have to rewrite the method. You have to rewrite the whole method. Okay, and it's troublesome. The other disadvantage is that once you exit IRB and you go in again and you try to call square again, you realize that the method has disappeared from memory. You get an error, undefined method square. Why? Because once you exit interactive Ruby, all the methods and all the variables in memory will be wiped out. Obviously, this is undesirable. Okay, you want to keep your methods somewhere so that you can use them over and over again. And that brings us to the second point. How do you load a Ruby file to memory? So the better solution is to write a method, or in this case, write many methods in the same file. This file is called method examples.rb, and load them into memory when you are in interactive Ruby. So method examples.rb is currently in the current directory in c/temp. Okay, I'm going to interactive Ruby. I use a load command, single quotation mark, and a file name. Now what has happened is that this whole file has been read. All the methods which I've written here, okay, are now in memory. I can use them. So for example, error equals to get GST rate. Now get GST rate takes in nothing, so I can do this if I want, but not really necessary. Alright, and R will get the value 0.07, which I can use down the road. Let's have an example. T equals to Fahrenheit 36.9, normal body temperature, correct? And to Fahrenheit, when invoked with the value of 36.9, it performs some calculation and it returns 98.419 Fahrenheit. So that is the value, that's the body temperature in F. Okay. Now another example here, area of triangle takes in two input parameters. So when I call it area of triangle, I pass in 6 and 100, it returns 300 units square. Now max here takes in three values. So when I call max, I'm going to pass in 6, 5, 2, and you return the biggest of the three. Okay. Yep, seems to be working. By the way, this max method only works if the three inputs are distinct. So it does not work if, let's say, the first two values are the same and the third value is actually smaller. You see? Okay, something is wrong here. If the three values are distinct, max will always work correctly. If the three values are not distinct, it may or may not work. So the homework for you is to find out what is the reason for this. Think about it, look at the code here, and come up with a method which takes in three values, distinct or not, and returns the maximum of the three. Okay, regardless of whether A and B are the same, it should return, in this case obviously it should return 100. I don't care whether it's the first 100 or second 100. Okay, think about that, that's your homework. Now let's move on. What is passing by value? Now it is important to understand that so when I call to Fahrenheit, I can always pass in a variable like A. A in this case is undefined, so I'll get an error. Okay, it says undefined local variable method A. So if I define A by assigning a value of the 6.9, I can always call to Fahrenheit, and instead of passing in a value, a number, I'm going to pass in A. Okay, now what is important to understand is that when you call a method, what gets sent over to the method is actually a value. So A doesn't get sent over here. What gets sent over is a copy of the value stored in A, which is 36.9. So whatever you do into Fahrenheit will not be able to affect the original value stored in A. So let's check the value in A now. It's still 36.9. Alright, so that may not be very significant now, may not seem significant now, but there are implications if you are dealing with other kinds of objects, right, which is not really in scope for this course. Let's move on to the last point here, scope of local variables in methods. Now, what do I mean by this? Okay, let's take a look at this method called to Fahrenheit. Now C here is a variable name. If you do not want to use C, you can use D. Okay, but C is a good name because C represents the value in Celsius. What I'm trying to say here is that this is a variable, and this is what we call a local variable. A local variable is a variable used only within a method. Okay, so within this method, C will have a value depending on what you pass in. If you call to Fahrenheit and pass into the 6.9, C will store 36.9. Okay, you perform this, you evaluate this expression. Okay, the 6.9 times 9 divided by 5 plus 32, and it returns. Once it returns, C is thrown away. You can't use C anymore once the method has completed. Alright, you can't use C anymore. So the scope of the variable C, or the scope of the local variable C, is only within the method from line 7 to line 9. You can't use C outside the method. So now I'm outside the method. When I try to use C, it says undefined variable because I have not given a value to C. Okay, even if I call the method to Fahrenheit and pass in 55 degrees, and hit enter. Now in the method, C is given a value 55, and then there's a calculation and returns 131. Once it returns, C is thrown away. C is not defined in the caller. Okay, now if I define C here and I call to Fahrenheit, okay, what happens here is 100 will be passed over to the method, and when it returns 212. Does not affect C here at all. Okay, what I'm trying to say here is that there are two C's now. There are two C variables. One, which is this one, and the second C is the one used in the method. Alright, now the C here and the C here, they are different, they are distinct, they have the same name, but they have different scopes, and they're independent. Alright, so you don't have to be worried about what kind of variables are being used by the person who wrote who writes the method. Okay, there won't be any conflict in that sense. You can use any variable you want. Even if there is a naming conflict, there's no problem because these variables have different scope. The scope for this C is from here to here, and when it returns, it is thrown away, and it's got nothing to do with if you have another variable called C over here. And that's all I want to cover for this unit.